here is our filtered sample. As you can see, just kind of comparison, right? This is much less cloudy, right? So we've successfully removed at least most of our sediment. Could set our unfiltered sample aside. And I'm going to transfer 75 milliliters of this into this flask. Now to do that, I have another type of volumetric pipette. So this one is designed to only deliver a single volume. So there's one mark here at the 25 milliliter mark. So I'm going to use this 3 times. But before I do that, I do want to go ahead and rinse this 3 times. So compress our bulb and go ahead and draw solution up into the pipette. Now because this takes such a large volume, I'm not going to pull up the full volume, I'm just going to do a quick rinse 3 times. Right. So now that we've rinsed the pipette with our desired solution, I can go ahead and begin filling the flask. And this is one of the disadvantages of the large pipettes, is that occasionally you're not actually able to get the full volume with one compression. Right, and that sometimes happens, I missed it, so gonna have to repeat the process, pull up again, and then carefully lower it down to the volume of the line. Right. I'm going to repeat that process 2 more times. All right, so 50 milliliters in. And the reason that we're having to use such a large volume of our sample is that, in theory, the concentration of iron in the river water, unless it's extremely contaminated, should be quite low. So hopefully it will take a large volume of this sample in order to actually observe the iron concentration. Maybe, come on. And sometimes this takes a few tries. There we go. Alright, so that should be it. So from here on out, we treat it exactly like the standard. So I'm going to add 1 milliliter of hydroxylamine, and then 10 milliliters of our phenanthrene solution, and 10 milliliters of our buffer solution. And once again, this can just be done in a graduated cylinder. Except for I've got a little bit of residual in there. There we go. So this is our hydroxylamine. And just as a reminder, this is to try to help reduce any iron 3 species to iron 2. Right. This is our sodium acetate buffer. And then last we have our 110 phenanthrene. If we've done this process right, there should just be enough volume to hold all of our reagents, plus a little bit of room for dilution. There we go, and as you can see, there's already an orange color developing, so that's a good sign that we've done this right. And then dilute to volume. And once again, we need to allow this 15 minutes for full color development. However, while we are allowing the color to develop here, our standard solutions have now set for over 15 minutes, so they should be good and fully developed. You can see our blank is colorless. We've got then a progression, right, as we increase our iron concentrations of weakly orange to then dark orange with our most concentrated standard. So now we can go ahead and move towards collecting our data for our standard curve.